All right, here we go with the WebAssign homework. It's on the ratio test. Bad start. Let me get rid of that. Okay, so the ratio test says you're going to take the limit as n goes to infinity of the n plus first term over the nth term of the series. And if that turns out to be less than 1, then it absolutely converges. If it's greater than 1, then it diverges. And if it is 1, you're out of luck. You have to use another test. So we're going to look at 17 first. It tells us to use the ratio test. So you take the limit of a sub n plus 1, the n plus first term. So I'm just going to make all the n's n plus 1. And you're supposed to divide that by the nth term, so just the regular 1 over 8 to the n. But instead of dividing, so it doesn't become a big mess, multiply times the reciprocal. Now you have to do all your cancellations and combinations and all that good stuff. Well, 8, there's a couple ways to look at this. This is n plus 1 eighths. Up top is n eighths, so there's one more 8 on the bottom. This is 1 over 8. You can also think of it as just subtracting the exponents. N plus, like they're the same base. So on the bottom, you just do n plus 1 minus n, which is 1. Either way, this is the limit as n goes to infinity of 1 over 8, which is less than 1, which means this series converges absolutely. So absolute convergence. And then, you may look at it and say, well, I knew that right away because it's a geometric series. It's 1 over 8 to the n. And you're correct. If it didn't tell us to do the ratio test, I would have just concluded right away this converges. It's a geometric series. But we're practicing this ratio test, so we'll stick with that. Let's go to number 19. Number 19 looks a little bit more complicated. We'll take the limit of m plus 1. So we have m plus 1 minus 1, which is n, factorial, over 4 to the n plus 1. This is all absolute value divided by this, so multiply by the reciprocal. So we just talked about how we're going to handle the exponents. If we have 4 on the bottom. Factorials, well, you just have to kind of look at they're all in order. This one goes up to n factorial. So the term before it at the top would be an n minus, if you multiply it all out, it'd be an n minus 1 right before it, and before that would be n minus 2. So just the numbers before n. And then on the bottom, we have n minus 1 factorial. So the last term is n minus 1. The term before is n minus 2. And everything before cancels out. So basically, we're just left with n on the top. Now, the limit as n goes to infinity of n over 4, well, that is definitely infinity. And if the limit is greater than 1 or even infinity, that's what the test says, you know that this diverges. Now, if you look at the original function, that should almost make sense here. It's a factorial, which is going to grow way bigger than an exponential function, even if there's one less term. So it looks like the nth term will definitely not be 0, so it will diverge. 21. 21 is the same thing. If you look at 21, we have n plus 2 times 9 over 7. There's no way the last term here is 0. So there's no way that this converges. It must diverge. With that being said, I'm going to do the ratio test anyway, because that's what it's asking me to do. So this would be n plus 1, or n plus 1 plus 2, n plus 3, times 9 to the n plus 2 over 7 to the n plus 2, multiplied by the reciprocal of this, which should be 7 to the n plus 1 over 9 to the n plus 1. I'm just writing like this because I think it's easier to keep those separate. And then n plus 2 on the bottom. So we have to go ahead and deal with this limit. Well, the 9s will cancel. We're left with 1 9 up here. We're left with 1 7 down here. Just look at the exponents. And then we have a n plus 3 up top and an n plus 2 on the bottom. So the limit as n goes to infinity for this function will be 9/7 because the degrees are the same. And 9/7 is most definitely greater than 1, so this diverges. And again, you could tell that the nth term test will tell you that diverges. So that's 21. I'm going to get down to the last one down here, 23. So here we go. Let me zoom in a little bit. All right, so 23, the ratio test says we're taking the limit as n goes to infinity of the absolute value of n plus first term divided by or multiplied by the reciprocal of the nth term. Simplify. We'd have 9 up top here, an n to the 5th, n plus 1 to the 5th on the bottom. Ooh. So this limit will turn out to be, it's the same degree. Leading coefficient up top is a 9. Leading coefficient on the bottom is a 1. This is definitely greater than 1, so this diverges. And again, not a really big surprise because this is an exponential function up top. There's a polynomial function on the bottom. The exponential function grows way, 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 way faster. So the nth term test also would tell us that this is going to diverge as well. So there you have it. That's the first few problems. The next video will give you the next few problems and so on.